Hey student, how are you? Welcome to our session on using the Pythagorean identity. We're going to use this information, so if you want to grab that before we move on, do that now. All right, here we go. We're going to take a look at three problems, and I'm going to do them two different ways. Number one, the angle theta is located in quadrant number 2, and sine of that angle is equal to 1/4. What is the exact value of cosine of that angle? All right, so I'm going to start by drawing our angle theta in quadrant number 2. Here is our angle theta in quadrant number 2. And then I'm going to use this reference angle right here in between the terminal side of our angle in quadrant number 2 and the x-axis. And I'm going to draw a right triangle. And we'll label the sides hypotenuse. This is the opposite side of our reference angle and the adjacent side. And they gave us sine of our angle is equal to 1/4. Sine is equal to opposite over hypotenuse. So the opposite side of our triangle in quadrant number 2 is 1, and our hypotenuse is 4. And now we can use our Pythagorean theorem, a squared plus b squared equals c squared, to solve for the adjacent side. 1 squared is equal to our hypotenuse squared, and we get 4 squared is 16. We'll subtract 1 and then take the square root. We get the square root of 15. Now, since we went to the left, this is going to be negative square root of 15, and cosine is negative in quadrant number 2. So now we can find cosine of our angle theta. Cosine of our angle theta is equal to the adjacent side over the hypotenuse. Negative square root of 15, cosine is negative in quadrant number 2, over the hypotenuse 4. And there is our cosine of our angle. Now, let's solve it a different way. We'll use our Pythagorean identity. And I'm going to write it sine of our angle theta, angle A squared, plus cosine of our angle A squared is equal to 1. Now we know sine of our angle is 1/4. So we get 1/4 squared plus cosine of our angle squared is equal to 1. 1/4 squared is 1/16 plus cosine of our angle squared is equal to 1. We'll subtract 1/16. Sine of our angle squared is equal to 1 minus 1/16. And 1 is equal to 16 over 16. We'll get a common denominator and subtract 1 over 16. And we get cosine of our angle squared is equal to 15/16. And then we'll take the square root to undo the power of 2. And you can take the square root of the top and the square root of the bottom separately. And we get cosine of our angle is equal to, we'll just put it over here so I have a little more room, square root of 15 over the square root of 16, which is 4. And this is negative because quadrant 2. So we do get the same solution. Now, which way did you like better? Let's do another one. Number 2. Number 2, the angle theta is in between 180 degrees and 270 degrees. 180 degrees and 270 degrees. That means we are in quadrant number 3, where both sine and cosine are negative. We had to go left and down to get to quadrant number 3. Let's draw the angle theta in quadrant number 3. Sure, right about there. Our angle theta, quadrant number 3. And I'm going to use this reference angle in between the x-axis and the terminal side of our angle and create a right triangle. And this is our opposite side of our reference angle, the hypotenuse, and the adjacent side. Now, cosine is the adjacent side over the hypotenuse. So our adjacent side is -2, and our hypotenuse is 5. And now we can use our Pythagorean theorem, a squared plus b squared equals c squared, to solve for the opposite side. And -2 all squared is equal to the hypotenuse. And we get a squared plus 4 is equal to 25. Oh, we'll make sure that you can see that. And we'll subtract 4. 25 minus 4 is 21. And we'll take the square root. Square root of 21 is our opposite side. And it is negative since we had to go down to get to this point on the unit circle. So now we can find sine of our angle is equal to the opposite side negative square root of 21 over our hypotenuse, 5. And now we'll solve it using the Pythagorean identity. Sine of our angle squared plus cosine of our angle squared is equal to 1. And we know cosine is cosine. We can substitute -2/5 all squared, -2/5 in for cosine of our angle, and we get sine of our angle all squared plus -2/5 squared is 4/25 equals 1. And then we'll subtract 4/25 sine of our angle squared is equal to 1. I'm going to rewrite as 25 over 25 so that we can subtract 4/25. And we're left with sine of our angle all squared is equal to 21/25. And then we'll take the square root to undo the power of 2. And you can take the square root of the top of a fraction and the square root of the bottom of a fraction separately. So we get the square root of 21 over the square root of 25, which is 5, and it is negative because quadrant 3. So there we go. And the last one, number 3. We'll do one more so you can figure out which method you prefer to solve. Knowing both is helpful just in case you have a problem that's phrased differently. Number 3, we are in quadrant IV, quadrant number 4. Here we are. There is our angle theta in quadrant number 4. I'm going to use this reference angle in between the x-axis and the terminal side of our angle to create a right triangle. And here is the opposite side, the hypotenuse, and the adjacent side. They gave us sine, which is opposite over hypotenuse. The opposite side is negative. We had to go down to get to quadrant 4, so that is -3. See that? And our hypotenuse, always positive, is 7. And we're looking for the adjacent side. So we'll use our Pythagorean theorem, a squared plus b squared equals c squared. And we'll solve for the adjacent side. -3 all squared is equal to 7 squared. We get a squared plus 9 is equal to 49. We'll subtract 49, subtract 9 from 49. We get 40. And we'll take the square root of 40. We can rewrite the square root of 40 as 4 times 10, and then take the square root of 4 out from the radical, and we get 2 square root of 10. So our adjacent side, 2 square root of 10. And now we can find cosine of this angle adjacent over hypotenuse, 2 square root of 10 over 7. And it is positive, cosine is positive in the 4th quadrant. And to finish it up, we'll use our Pythagorean identity, sine squared plus cosine squared is equal to 1. We know sine is -3/7, so we will substitute -3/7 in for sine squared, -3/7 squared plus cosine of our angle squared is equal to 1. Negative 3/7 squared is 9 over 49 plus cosine of our angle squared is equal to 1. We'll subtract, and we get cosine of our angle squared is equal to, I'm going to rewrite 1 as 49 over 49 so that we can subtract 9 over 49. And we're left with cosine of our angle squared is equal to 40 over 49. And then we'll take the square root to undo the power of 2. You can take the square root of the top of a fraction and the square root of the bottom of a fraction separately. And we know the square root of 40 simplifies to 2 square root of 10, and the square root of 49 is 7. And that concludes our session on using the Pythagorean identity. Thanks so much for joining our session, and I'll see you next time.